Your vibe-coded apps are not secure. In fact, there's a good chance they contain one of the major issues listed in this video. I'm a solutions architect. I've studied over 20 vibe-coded apps for this video. I've deployed my own vibe-coded apps into production, and I've researched what others have hit in the real world as well. In this video, I'm going to provide you with a checklist with the most common security issues I'm seeing with vibe-coded apps right now and how to resolve them. So let's get started. And I think we need to start off by talking about database security. Now, you may have noticed AI will naturally navigate to some back-end as a service tool, something like Firebase and Supabase. And if you coded your own projects before, you know this is a pretty good place to start. They're easy to use, and most importantly, they're easy to get off the ground running. And let me start by saying there's absolutely nothing wrong with those services. They just work a little differently than historically we're used to. You see, these services actually allow you to, and encourage you to, call them from the front end, removing the need for a dedicated back-end service. The only problem is that on those back-end services, we used to get full isolation and full security. But that's not really the case on the front end. We have no real power there.
You have no power here, Gandalf.
I mean, sure, we could put up some guardrails, but realistically anyone can modify the request that gets sent up to the server. And that gives a big attack vector for potential hackers. So let's say I wanted to send a request to get back all of my user data. If it's coming from the front end, I can actually modify that request and change the parameters and say, hey, give me someone else's data. And this is where row-level security comes into play. It's not enough that somebody is authenticated into your app. We need to identify the user ID and ensure that when they do look for the data, no matter what they search for, they only get access to data that they should have access to. So if they sent a request to the database to get all entries of user data, they'd actually only get their own. Now, this row-level security needs to be applied throughout the whole database. And it's something AI can actually be quite bad at doing, and sometimes it won't protect the correct fields. So if you're using one of these back-end as a service tools, you're going to want to make sure that users can't access other people's data, and users can't modify data that is set by the system. For example, subscription levels, price, rate limits. You'll need to do this for every single table in your database, but it'll protect you from users going off and accessing data that they shouldn't. All right, let's talk about admin endpoints. AI loves to create a dashboard and admin functionality. This is something that actually used to be a lot less popular, mostly because developers couldn't be bothered to go and create an admin dashboard. There was just no real point. They took a long time to make, and to be honest, you could do all your admin privileges just from the CLI and do it yourself. But now AI can build out these dashboards so easily and so quickly that it's probably a convenience worth having. For example, allowing you to do bulk operations like deleting users, resetting data, and exporting everything in your database. Problem is AI doesn't always protect these endpoints appropriately. So you might end up with an endpoint of something like API admin delete all users that's just sitting there. Publicly accessible, no role check. No special token, anybody who knows the URL can just access it straight away. Now, when I was doing the research for this, I found multiple times that AI will put in an admin role for some of the admin endpoints and then just completely forget to do it on the others. It gives you just enough confidence that it's protecting you, and then you realize the endpoint that it didn't protect is the one that can delete all of your data. Luckily, this is an easy fix. You've got to go through every endpoint and API route in your app and ask yourself, should it be accessible from a non-logged in user, a regular user, or an admin? And obviously expand that out to however many roles you have in your application. But make sure you double check any admin related endpoints and make sure that it can't just be done by any logged in user. Honestly, this is scarily common. It will only take you a couple of minutes, and I promise you it'll be way worth it. If you are finding this video helpful, please consider liking and subscribing. This is a very small channel, so if you don't click the button, you probably won't see one of my videos again, which would be very sad because we've got some cool stuff coming up. Anyways, let's talk about user verification. You know those annoying user verification emails you always have to do when you set up a new account? It seems like a small nice to have feature, right? Well, not implementing that actually has two major problems. The first one is fake users. Without email verification, people can create as many users as they want. This not only pollutes your existing user database, but it also allows people to abuse stuff like free tiers and trial limits, which can end up costing you a lot of money for no real paying customers. But the second problem is more serious. And that's that without proper verification, people can actually use that login endpoint to get information about your system and your login structure so that they can hack it. They can use that login screen to silently probe your database and your user system, especially if your app is giving way too much information on those error messages. Your login endpoint should always be offering the minimum information possible on failure. Instead of saying invalid username or incorrect password as two different events, it should just say invalid credentials. Because that can allow an attacker to figure out what elements they got right and figure out what users and email addresses are in your user database. So the fixes are simple: check your responses on your login endpoints and make sure they're not too verbose, and turn on email verification. In something like Supabase or Firebase, this is just a tick button that you can click. It's super easy. All right, now let's cover API keys. This is probably the most common and most dangerous. It is genuinely scary how many results you get back when you start searching for API keys in GitHub. And that's because when you ask an AI to connect you to something like Stripe or Supabase or something like that, it often just puts the API keys in your code, just directly into the front end. And I get why it's doing it. It's the quickest way to actually make the connection work. But here's the problem. Your front end code is public. Anyone can go onto their browser, click inspect, and see your API key just sitting there. It's not even hiding, it's just right there. The fix is that API keys should be stored in environment variables on your server, never in any front-end code. And after you've moved your keys, I'd recommend searching the entire codebase for any examples of keys or any common API key patterns. And if you've got any .m files, just make sure that those aren't committed to source control. You can do that very simply using a git ignore file. Next, we're going to talk about payments, which is something I feel strongly about because it affects your users' money. Here's a scenario. A user clicks Pay Now. The spinner appears, it's taking a few seconds. The user thinks it didn't work, they click Pay Now again, and they get charged twice. This is a raise condition on your payment button, and I've noticed it's extremely common in AI-coded apps. And that's because the AI likes to build the happy path. It makes the button work and does all the testing, but it doesn't consider, hey, what happens if the user clicks it twice? You've got two potential fixes for this, and I think you should implement both. First, you want to disable the button immediately on the first click and show a loading state. And second, you can implement idempotency keys with Stripe. These are unique keys that you attach to each payment request, and Stripe recognizes them and says, hey, don't charge this twice. And of course, you want to make sure that you're doing your payment verification on the server and not the client. As a general rule, don't trust anything that comes from the front end. Always confirm with Stripe's webhook before you fulfill anything. All right, now we've sorted user payments, let's talk about our own wallet. We have a couple main areas to worry about here. Firstly is any infrastructure costs. Whatever services you use to set up your infrastructure, just make sure you've got appropriate budget limits and budget caps set up. You do not want to be waking up to a $100,000 bill because someone got hold of your API key and started abusing it, or someone spun up way too much infrastructure and jobs for you to handle. Because let's say someone was able to get hold of your AWS key. They could do Bitcoin mining, whatever they wanted to do really, and you'd be the one fitting the bill. But if you set up budget caps and budget alerts, it can really stop things from going out of control. I know it takes a few minutes to set up, but trust me, it's worth it for the peace of mind. And secondly, we've got rate limiting. Now this is especially important if you have AI capabilities as part of your app. You need rate limits to prevent users from spamming your endpoints. You do not want to get spammed by a million requests by one user on a free tier, just using all of your AI credits. Otherwise you could end up spending a lot of money very quickly. So be careful, set sensible rate limits on each of your users, and pay a special attention to any AI integration tasks. Alright, so to recap, here's your checklist. On the security side, we've got row-level security, auditing your admin endpoints, making sure you have email verification on, and checking any API keys in your front end. Then on the payment side, we're going to make sure that we're not duplicating any payments, we're setting sensible limits for the infrastructure and the budget spends, and we're also implementing user rate limiting. You'll notice none of these are very difficult to fix once you know about them. The dangerous part is just not knowing where to look or to assume that the AI has handled it all for you. But hopefully with this checklist and with this knowledge, you'll be able to handle any issues that might arise. Don't forget to like and subscribe, and I'll see you in the next one.